So now let's go to the fun trig problems. You're ready for this. Okay, so here's my equation. Here's my given rate, right? So I want you to start to get used to this. That's my equation. That's my given rate. Here's my when information. And here's my find rate. Okay, so let's take my equation. So A equal 4 sine theta. I'm going to take the derivative with respect to t on both sides because I can see that. This left-hand side is just dA over dt. This right-hand side, I carry the 4, take the derivative of the sine, which is cosine, carry the angle along, and then don't forget, take the derivative of the angle with respect to t. And that's what this is. So then this says, plug in theta is pi over 3. So I get cosine pi over 3. And then d theta over dt. Let's look back and see what that is. D theta over dt. Oh, that's 2. So I multiply by 2. And then I can find dA over dt. So I know I've got 4 times 2. That gives me an 8. And a cosine of pi over 3. That gives me a 1/2. So that's a 4. All right. These are going to get a little harder, but you are ready for it. Let's see what we got here. So here's my equation, my given rate, my when information, and what I need to find. So if I take this cosine of theta is equal to x over 5. So let's be careful and just rewrite that as 1/5 x. So if I go take the derivative with respect to t on both sides, so this gives me a negative sign, carry the angle along, and then multiply by the derivative of the angle, equals, carry the number 1/5 along, and take the derivative of x, which is dx over dt. Okay, let's look to see, erase all this stuff, see what I've got here. So I've got dx over dt is 6. So that's 6 times up 1/5, right? Equals this here, this d theta over dt is what I'm trying to find. So I'm just going to carry it along. And then I want to find sine of theta. Oh, wait a second. They don't give me anything about sine of theta, do they? So what do they say? When x is 3. Arg! No place to plug in x is 3. But wait, can we put x is 3 back into the original equation? If I put it into the original equation, I get this. And of course you're thinking the triangle, right? So it's adjacent over hypotenuse. Since I know cosine is adjacent over hypotenuse, can I find the side? Yes, 3, 4, 5 triangle. So what does that mean that sine of theta is equal to? So sine of theta is 4 over 5. So that's what I do, is I take this out, and put in 4 over 5, carry the negative sign along, times d theta over dt equals 6/5. Wow. And I know I can simplify that, but that's kind of okay to leave it just like that. Okay, one more. Oops, let me make some room. Okay, so here's our equation, our given rate, right? So you're looking for these things. Equation, given rate, some when information, and what I need to find. A find rate. Okay, so they're telling me that tangent of theta is 1 over x. So let's go and take the derivative. So I'll just write it over here. Tangent of theta is 1 over x, and I like rewriting it as x to the negative 1, so that when I go to take the derivative in the next step, it's ready for the power rule. So derivative of tangent is secant squared, carry the theta, then take the derivative of theta, which is d theta over dt. Okay, equals. How do you take the derivative of this? That's going to be negative x to the negative 2 times a dx over a dt. Okay, so let me just write it over here and see what I can plug in. So this is saying d theta over dt is 3. Okay, so I'll put that 3 in. Secant squared of theta, oh yeah, secant squared of pi over 4 equals, and I'm just going to rewrite this term here as the fraction that it is, right? So if I want, I'm trying to get a different color here. Okay, so this is like saying negative 1 over x squared, right? Times dx over dt, and that's what I'm trying to find, so that's okay that that's there. So now I have to stop and think, I can figure out, let me erase up here so I can show what I can figure out. This is one of the things that I told you would be really useful to memorize, that secant squared of pi over 4 is 2. So let's put 2 in for that. And then I have this times 3 equal a negative 1 over x squared times dx over dt. So what do I need to do? The goal is to find dx over dt. So I just got this missing x. So how am I going to solve for x? So if I look back at my when information, can I plug pi over 4 into my original equation? I can. So if I put in pi over 4, tangent of pi over 4 is 1. So I get 1 equals 1 over x. Oh, that means x is equal to 1, and that's what I can plug it in. And so then I divide, so I get negative 6 is dx over dt.